Hi, everyone. Welcome. Thank you for joining us today. My name is Monika Gandhi, and I'm the Outreach and Recruitment Specialist in the Marketing Department. While we wait for everyone to settle in, let me tell you about UCSC Silicon Valley Extension. We are the Professional Development Division of UC Santa Cruz, located in Santa Clara, California. We offer courses and certificate programs for working professionals to update their skills. Our courses are designed by experienced instructors who are actually working in their field currently. And three of them are joining us today to talk to you about artificial intelligence and robotics. We have Bipin Thomas, Sudhakar Ala, and Dr. Moenis here with us today, who are all instructors at UCSC Extension. I will link their bios in the chat shortly. Before I hand it over to them to begin, we ask if you have any questions during the presentation, you can submit them in the chat at the bottom of the screen. I'll help facilitate these questions to our speakers throughout the presentation. And we'll also have time at the end if you'd like to ask your question to our panel. You can simply click raise hand and I'll unmute your mic. Thank you so much again for attending, and I will hand it over to our panel.
Yeah, thank you. Thank you, Monica. And good afternoon, everyone. Thanks for joining us this afternoon. I know it's a pretty busy schedule for everyone, and also working remotely and connecting via virtual platforms. But I really want to thank you for taking the time this afternoon to spend a few minutes with us. We have a great panel, as Monica mentioned. With me, I've joined with Dr. Munas and Sudhakar. We're going to talk about artificial intelligence and robotics. In that context, I'd like to bring up the convergence that's happening in the AI and in robotic space. I'm sharing two, three slides as backdrop for our conversation in the beginning, and we will then branch off to the job opportunities that are open in robotics and in AI. Which Dr. Munas will highlight quite a number of those areas in different industries. And then it's also, we want to connect this to the upcoming curriculum and the course that we have structured as a part of the AI specialization process, which Sudhakar will be an instructor to guide us through that. So that would be our overall structure for the webinar. To begin with, as we all know, robotics has been there for ages. There's a lot of automation in terms of repetitive work that have been handled by robots in whether it's the manufacturing, shop floor environment, warehouses, in medical, healthcare, in several of the industries we've seen the role of robotic capability. Primarily, we've seen in automation of the shop floor environments where there's mass production of whether it is cars, vehicles, products, the entire supply chain for the manufacturing and industry 4.0 has been predominantly robotic driven. And from there, we are seeing the process of moving this automation into several other new industries in the recent past, especially the last 10, 15 years. And then in the last 4 or 5 years, applying artificial intelligence in making those task-driven, repetitive-driven to more intelligence-driven. And that's one of the areas that we've seen robots have progressed, and which means there's more applications of AI and use cases where the enterprises are really tapping in to apply the value of artificial intelligence in these robotic capabilities. So it's not just about building an automation framework with hardware and software, but also taking it to the next level of applying intelligence to it, and by involving more sensors, just like the physical world has been impacted with sensors. How can robots be subject to those visual cues of sensors and cameras, whether it's cameras, lidars, and all the sensor fusion that brings in that data points to really take on those tasks more intelligently and perform those tasks more intelligently. So closing the loop is where the robots really comes in bringing that intelligence and then actually acting upon that intelligence. And of course, for automation and employment, there's a huge convergence that's happening in these two sectors, which causes more opportunities for employment as well. With that, we talked about also the collaboration with the human beings, and that's actually happening in the shop floor. In the shop floor, as you can see, technicians are working very closely with robots on the floor in order to implement certain tasks, to do inspection, assembly, quality inspection. And so the first industry that I like to highlight is the manufacturing industry, which is called Industry 4.0. There are robotic companies like Universal Robots, ABB, that are more leading companies in there that have really captured the market share. But now they are moving towards more of an AI-led marketplace where there is a need for these capabilities to be enhanced with AI and intelligent software that is governing the entire supply chain of these smart manufacturing companies. Healthcare is the second industry that's also heavily impacted with the human robot interaction. The capabilities of surgical instrumentation that are now robotic driven is actually strengthening and augmenting the physicians, the nurses, the clinical personnel in healthcare. So it is seen as an augmented intelligence to what they're already doing. Service industry across, including retail industry, that we are seeing a tremendous human robot interaction and collaborative robots that are taking ownership in that space. And then we're seeing increasing the autonomous capabilities that are driving more complex tasks in those environments. So in general, there are several industries that are being driven. It's needless to say about the automotive because we've already seen and using self-driving cars and autonomous cars on the streets. So we're already part and parcel of it. But this is more in the industries where the enterprises are transforming themselves with the human robot collaborative intelligence that makes more productivity and delivering more precise quality and standards possible within the enterprise standards. The AI for robotics, if you really look at the architectural level, so a little bit to go deep into the architectural level, you can think of it as a distributed system. Where there is three components. The cornerstones of those are the distributed computing, which now we know about cloud, the role of cloud in distributed computing. We are, very much in the learning curve of the edge systems, where the edge is now taking more prominence in making decisions and collecting data as well as sensing and decision making. So whether it is cloud-based systems or edge-based systems, there is a distributed computing that is now made possible. All the enterprises in this industries we talked about are bringing a combination of cloud and edge processing. It's not just limited to cloud, but it's a combination. It's a hybrid of the two. The second most important thing is distributed sensing, because sensors are now not just connected on a device or a machine or on a equipment. It is now available everywhere. You can collect sensor data, whether it is from cameras or LiDAR-based systems, or if it is from IMUs or any of the chipsets that are monitoring certain parameters. It can be sensed and sent to processing. It could also be data sources from enterprise systems in a large organization. They can also be a time series data that is coming from various data sources within an enterprise. So all those can be sensor data retrieval and storage, which crosses the sensor systems as one of the most important part of the architecture. And the third, which is the most important, is the actuating systems, because now you can derive intelligence off of this machine learning systems that are running in the cloud and edge, along with the sensor data that are coming in. And the intelligence that has been derived is now fed back into an actuating system like a robot to take action. So it's a closed loop system. Otherwise, AI would be more or less like another IT system that is providing a bunch of dashboards again to the human to act upon. Here, that intelligence is acted upon back to the actuation model, so that these robots can actually perform that task based on the intelligence the machine learning system has actually inferenced upon. So you can see the intersection of AI delivering intelligence and system delivering intelligence, and the actuation being done by robotic systems to act upon that intelligence. So it becomes a full 360-degree view of that decision-making process rather than bringing human in the loop to make the decision. Now, human can be on the loop, but the machines take the decision and act upon it. And that's a very interesting, fascinating intersection we are seeing. And because of that, there's quite a number of AI robotic solutions that are emerging in the marketplace. And we want to talk a little bit more about that with Dr. Monas in terms of some of the solutions that we are clearly seeing that are being applied by enterprises in these industries, and what skills and job opportunities that are there in each of those industries. So with that in mind, let me I'll also take a pause here for any questions if there is, and then have Dr. Moniz, address some of those industries where we are seeing applications of this in certain use cases, and also some job skills and job opportunities that are emerging because of this transformation that's happening in the marketplace. Thank you.
Hi, Bipin. There are no questions in the chat yet.
All right, great. And then let's have Dr. Moniz speak for a few minutes, and then we will branch off to Sudagar regarding the overall structure of our outline.
Thank you, Bipin. Thank you, Monica. And thank you for everyone who joined. My name is Monika Escaros, and I've been actually working in robotics for quite some time. When robotics was mainly for research and interesting area for graduate studies and PhDs, and very limited application in industry or outside of academia, other than, of course, industrial and automation. This has been going on for quite a long time. But since then, lots of things changed, and especially with the emergence of AI and machine learning again, after a long time where there was not really the right ecosystem for them to be able to be fruitful. Now robotics is really benefited a lot from the new directions and ecosystem with AI and machine learning. So in addition to industrial and automation, areas like service robotics, logistic, medical, even for security and surveillance, delivery, and also applications where robots interact together, like cobots, or interact very closely with humans in the service industry, in aiding with the people with disability, and so on. So a huge growth that is just started to happen, and the growth is even going faster, and it's not plateauing at any point. Lots of new applications and ideas, and even in the entertainment industry. In addition, of course, with the autonomous platforms and autonomous vehicles. With this, lots of opportunity come in terms of work and career, and developing skills, and lots of challenges. So now we're talking about safety. Also, we're talking about edge processing, which means that we want to do the processing as much as possible, and the understanding and the intelligence and the decision making and actuation, all within the robotic platform at the edge, rather than going all the way to the back end, and having the communication and latency, which delay things because of latency. Also, it adds a lot of power and the great performance. So this is other challenges, and there are now good solutions in terms of the hardware and the accelerators and embedded processors for edge intelligence, in addition to the ecosystem, the firmware, the robotics operating system, and other tools that enable it. Many use cases now are end-to-end, which means that it's not just the involvement of the gathering data, but gathering, understanding, decision, and some communication with the back end for specific needs and analytics and a large ecosystem of the use case. And with this, lots of opportunities in terms of developing skills and utilizing the different skills. So robotics is really multidisciplinary ecosystem. It has mechanical systems, it has sensors, embedded hardware, embedded software, lots of software development, sensor fusion, machine intelligence or machine learning, and a lot of AI, especially now with the advancement in computer vision that improve the perception, understanding the scene around us, localization with using vision, understanding the different objects, relation. So it's really a very very high level and sophisticated level of perception that would enable the planning and decision making and actuation. All these are new skills that people can learn as they are building robots, and the best thing is to do is really to be involved in building a system, part of it, or within a group that built the entire system. You learn a lot from the mechanical side, from the sensors and software and AI and so on. Applications are now really there's a boom in the different applications and needs, and companies every day now I learn about new companies or companies coming out of stealth mode that are working in robotics or supporting robotics or building a different ecosystem or software ecosystem for robotic applications. So this is really an area, to me, I really enjoy it because it's truly a pleasure to build something that materialize and you can see it moving and working. It's also an embedded development and involve lots of different things. So with this, I don't want to take too long time, but I'll be happy to answer other questions or any questions that come, and I'll turn it back to Bipin and Sudhakar.
Yeah, thank you. Thank you, Dr. Moniz. So let's take a brief pause here and see if any questions, Monika, from the attendees.
Vipin, no questions are coming in so far. I think everyone's very engaged.
Very good, very good. Yeah. So with that, let's segue to the overall structure of how we are looking at specializing the skills and the structure necessary to build upon the skills from someone who is coming new, as well as someone who has some background in the robotics or AI, in preparing themselves towards getting opportunities in this space. As Dr. Moniz outlined, there are numerous roles that are being announced by large enterprises that connects the robotic experience with AI. And then we have, because of that same reason, we have structured this in a skill building pathway towards getting readiness for this industry jobs, as well as knowing the use cases that are mostly critical for those businesses to apply them from an AI and robotics perspective. So with that background, let me have Sudhakar, who is going to be a co-instructor with us in enabling this within UCSC Silicon Valley Extension, take a few minutes to give you with an outline of that skill building process and give a little narrative on that. Sudhakar?
Thank you, Vipin. Monas. So, hi everyone. My name is Dr. Alla. Thank you for attending. So, I'm a machine vision engineer from Sacramento, and a lot of the things Dr. Monas and Vipin have brought up are like the big reason I do what I do. So, there's so many use cases nowadays that we can kind of like have at the convergence of AI and robotics that I've gotten to work on doing things for like robotics in disaster zones, robots that restock and count inventory in warehouses. We've applied computer vision to detect material defects. We've used drones to find cracks in roads so we can fill them up, like fill potholes and things faster. So the applications are really endless, and like it's a really good time to kind of find your niche. Like if you have a little more data science aspect, and there's a lot of robots that do that kind of analysis. There's a lot of computer vision and actuation as well. So we kind of structure the course to take advantage of these things and give students an introduction to these variety of topics. So the majority will be based on robotics. We will be going through the actual architecture of how sensor fusion, how distributed systems and things like that play major roles. But from there, we will actually, the remaining 3-4 weeks of the course after our introduction will be focused on allowing students to kind of find where they can like kind of like find their sweet spot. So we'll be doing computer vision, NLP, actual like human robot interaction use cases. We'll be looking at even deep learning and other neural network approaches. So our course kind of allows for everyone's like questions to be answered kind of. So our idea is kind of let students like design, develop, and deploy AI applications. We will actually even be going through and applying, deploying our own computer vision application on a robot. So that's part of our course capstone. By the end of the course, also, we'll learn how to pretty much translate industry use cases for robotics and AI into large applications and POCs.
Yeah, thank you. Thank you, Sudhakar. So could you elaborate a little bit more, Sudhakar, in terms of what is necessary from a skill set standpoint to drive this learning process? Does one have to be a machine learning engineer to begin with, or has some Python skills or some programming skills? They can get the next step in learning and applying this outline that you just mentioned in becoming an AI experienced person for robotics. Could you elaborate on some of the basic skill necessities there?
Right. So that's another kind of big blocker for people entering this field. They think you need to upfront know high-level mathematics, computer vision, things like that. So that's not always the case. So in this course, I think having a good understanding of some programming language, whether that's C++, Python, even Java, something like that's okay. Like just have some object-oriented background so you understand how the pieces fit together. And from there, we can really like blossom your education. Like we can talk about how you can apply your object-oriented principles and learn computer vision or neural language processing or whatever your interest is. Understanding kind of high-level like programming languages. If you have some background with algebra and even like calculus, that would be great. But outside of that, I think most backgrounds, like as long as you come in with an open mind, we can actually be fruitful.
Great. Yeah. Thank you. I think that's very important from a skill transformation perspective, because we are seeing the process of customers willing to engage with these jobs and emerging job opportunities in this area is a pretty wide range. So you don't have to be really locked in with the machine learning or a specific competency within that. There are examples where I've seen people very successful in starting just as a test engineer in the testing piece of a robotics framework for some of the large customers. And then because customers also feel like, or the large enterprises feel like, there is going to be a lot more ability for people to pick up the knowledge, the experience by testing some of the robotics capability and AI capabilities that they've ingrained in the recent past, and gradually legging into that process than having to have all the prerequisites and expertise that one needs to have before they even start that particular job. So now that there's this huge lack of skills, the enterprises are much more flexible in engaging people at different stages of the project, where they can gain that know-how by becoming part of the team, which in this testing and running through some test plans and test frameworks makes it easier for someone to build that skill along with the job, and then gradually go into the maturity levels of AI with robotics. So that's also another channel or pathway that we have seen from a skill building to get to some of those job readiness opportunities in the marketplace.
Actually, if I may, I'd like to add one point here. Is there are now lots of frameworks and libraries and reference designs and reference code that is available. So if somebody has a good foundation in software development and integration, he or she doesn't have to be an expert in machine learning or algorithm or developing actual deep learning networks or sensor fusion, because lots of these are now available as libraries. And I always say that if anybody has a good new idea, there could be at least 5 different ways of implementing it, depending on the level of sophistication and application. But it's way now better and easier to acquire these skill sets now than before.
Yep.
Thank you so much. And
really quick here.
Mhm.
So I think we had a question from Roger. So we were talking about what kind of hardware we would want to use for this course. So just like Mona said, like it's really easy to kind of come into this field, and that's kind of how we want this course to be too. So coming in, as long as you have an internet connection and computer, we should be fine. We've set it up so that we can use a third-party vendor for free like virtual desktops, so we can do a lot of our development there, and there's no restriction on what hardware you come into the course with.
Awesome, thank you. So we do have a couple of questions that have come in. One is, what sector are you seeing the most entry-level job demand?
So I'll start with that. I think in the Bay Area, if you're living here in the California Bay Area, you've certainly seen a lot of autonomous driving, that is self-driving vehicle companies right here, and that's a network of companies. It's not just the end product building company like a Tesla or a Neo or Lucid. There's several of them, Zeres and Waymo, Baidu, Uber. So there's lots of companies here that are driving that. But at the same time, there's also a lot of smaller companies or suppliers that are developing solutions for them, whether it is testing their autonomous driven data, what the sensors are capturing, and building, creating a ground truth environment, and also benchmarking them, validating it, looking for error frameworks. So there's quite a number of companies, and from a sensors perspective, from a compute perspective, there's quite a number of companies that are also partnering with these large corporations. So there's lots more job opportunities even with them. That's, I would call this as the next level of companies, and even startups in the Bay Area that are feeding their solutions and IP and products and solutions for these companies. So we can imagine that as one of the major growth areas here in the Bay Area. And there's a lot of job opportunities that we are seeing daily published. If you look up most of the public job portals, there's numerous openings being announced by all this hierarchy of companies in the Bay Area around the automotive self-driving space. The second industry that I can think of here is this in the high tech industry, and high tech industry right here in the Bay Area itself is transforming much faster and applying robotics in all the areas of their business. So image processing, computer vision, which Sudhakar talked about that. So there is a lot around vision technologies in these companies. Looking to look for different detection using AI and robotics, improving productivity using vision. So that's another industry that I would suggest, especially in the Bay Area, that are very much in the hiring spree right now. And there are many, but at least the two of them to call out.
Excellent. Thanks so much, Vipin. Seeing if there's any other questions. I did put some links in the chat that talk a little bit about the series that we have that's being built out, and it definitely varies on the interest in the different topics that we have in artificial intelligence. So if anyone does have questions, you're welcome to contact us and our student services team, and I'll put that info in the chat. Looks like those are all the questions we have so far. David, does that cover everything for today?
Yeah, I think one of the aspects that we could also talk a little bit about is the overall the navigation of how a student or someone needs to build the skills from start to finish, and the progressive nature of building and applying in different industries, because we are pretty much seeing a use case driven approach even in the marketplace, in the job marketplace. They are asking for not just technical skills, but how you apply them, and what are the outcomes that someone can help experience those from implementing these tools and capabilities. So it's a very outcome driven world today. So how can we help building the skills and the readiness programs towards more outcome driven for the enterprises? Because today's hiring has also changed. It's not just a skill to skill match that the companies are looking for. They are wanting to see how you would be part of their transformational initiative. How can you drive outcomes for the company or the enterprises in the roles that you're going to be filling in? So the conversations have switched towards the job interviews, and discussions on jobs have been is more towards outcomes. So it's very important to be cognizant about what we do from a skills and readiness perspective impacts the outcome of an enterprise. So if it's a self-driving car company, or a software company that supports a self-driving company, or a hardware company that supports a self-driving organization, or if it's a manufacturing company and high-tech company, how are they driving productivity improvement, quality improvements, improving the throughput or the order fulfillment process, and how is AI impacting it with robotics to deliver that? So as in a case in point is, suppose you order something in Amazon or any of the online retail channels, the systems actually try to recommend a product for you, and there is an element of product recommendation AI algorithms that run behind the scenes in order to project the right products or the mix of products to a customer. And as they choose and place that order, it actually comes through an order fulfillment system that is given to an AI system that branches this off to where the right location is to find and fulfill the order. and it actually dispatches a signal to the robo on the warehouse, a robotic system on the warehouse that actually picks the item, or focuses. If it's a human picking system, it gives that command to the human picker system that actually picks the item, uses a robotic system to scan and take it from location A to location B, where it's packaging and transportation of that packet or the package to the end consumer who ordered the item. So as you can see, there is an end-to-end process that is getting fully automated, and robots play a very key role throughout the value transformation of this enterprise. And that's where the transformation of the industry is happening, in becoming more of a ecosystem player rather than an industry-wide transformation. And in this kind of examples, you can see a robotics and AI acting at every stage of the way. It has become a fabric that connects and integrates. It's become very seamless. Earlier, in maybe 10 years ago, robots used to function in certain stages, and that's the start and finish of the application of robot. But it's kind of a fabric that feeds into the entire business process of a companies, and that's the reason why companies are looking for, as they hire people, that what would you do to impact the outcome? What is your impact in the business outcome of the company? What role are you playing? The skills you're bringing to the table has that positive output and income, and the outcome that is necessary for generating the KPIs or the monetization of their new cross-channel systems, or the monetization of a new market share, or building a new revenue channel for growth. All of these things are being now looked at from this dimension. So every job opportunity that we are seeing is now has a direct trace and a linkage to these business outcomes that I just outlined. So that's something to kind of bear in back of your mind as you build skill and learn. Need to see how it affects and impacts the enterprise value chain of these enterprises that we spoke earlier.
Thanks so much, Vipin. It looks like we do have a couple of questions. During the course, will we have opportunity to apply reinforcement learning and neural network into physical hardware on hand and see how they work with the hardware? If so, which course will provide this kind of aspect?
Great. Yeah, that's a great question too. I'll have Sudhakar speak about it, but before that, maybe give a little overview about the structure we have given to this. We've spent a lot of time evolving and developing this outline for this course, because we know we will have attendees from different experience levels, different technology levels, and different software and hardware engineering levels. So it was very important for us to find the right balance. But I think sounds like if you have experience in deep learning systems or any of the neural networks, that'll definitely be very handy, because then you can actually do some intense image processing and image recognition systems that are very important, because we talked about how robots see the physical world using its sensors. It'll be mostly based out of cameras and the lidars, how it senses where it is and localizes itself. So it's a very important image processing system that are being trained in convolutional neural nets. And you will have the experience and the exposure to actually take those images and do the convolutional neural net training, and then prune those neural networks, the inferencing, to run on the edge. So edge hardware becomes very important, and we have pretty much standardized using NVIDIA's AI edge systems, because they are system on the chip computer systems that are much more applied in today's world, especially in large enterprises who have embraced the SoCs from, or the AI at the edge systems from NVIDIA. They've been very helpful in applying this pruned algorithms to execute inferencing at the edge. So you could actually also take your trained model from the cloud, as Sudhakar mentioned earlier. You can have a cloud system or any virtual machine that can be set up to train your system on the cloud during this process of the course. And then once it's get trained, you can actually flash that to a physical system, a physical robot, which is the edge system, and see how the inferencing happens in the real world. So one of the case studies that we are pretty passionate about is if you have a bunch of products on a shelf. Let's imagine a Walmart store shelf or a Target store shelf. You have so many consumer products on the shelf, and if you take those images, and those images can be easily found. I mean, you can get those images of whether it's pocky sticks or macaroni cheese or a bottle of water, any of those products that are sitting on a shelf. You can take those images and train yourself a deep learning algorithm, a convolutional neural net algorithm to detect those images. We were going to be helping you apply that in a physical robot, and as robot approaches that shelf, it's going to detect those items, and you'll receive the order to pick which item. If it's a macaroni cheese, then it's going to pick that box because it now senses from a wide range of products sitting on the shelf. It gets closer and locks it in order to apply the robotic arm to move towards an extent and pick up that that robotic action to pick up the item and bring it back to the to the packaging and the transportation, the wing of the building. So it's very important to see how all these deep learning techniques can really be applied, and we will be enabling as a part of this course to get that hands-on experience in applying it to the robot. With COVID situation, obviously, some of these things will have to be done remotely, so you'll be able to remotely see this through a Zoom meeting, how this robot that has actually taken the deep learning algorithm, the pruned algorithm for execution, and how it's detecting and acting upon it. So you'll be able to visualize it through a real-time video, or we can capture it and share it with you. So certainly, those are some things that are being orchestrated as a part of the coursework. Sudhakar, want to add to it?
Yeah. So, I mean, we won't necessarily have reinforcement learning as sections because, like Bipin mentioned, we wanted to make it a course open to all levels. But that's a great interest, and that's something I think week 5, the way we've structured it is a lot of it is just everything the students are interested in. Those are the topics we're covering in the last week. So something like reinforcement learning then could definitely come into play. And as for your question on will we be able to load it onto hardware, so we'll be loading some things onto hardware. We'll be loading things onto like a Jetson Xavier and things like that. But that will be in a structured fashion where we will only be loading certain models and stuff like that onto it.
Thank you so much. I have one more question, and that is, this person is saying that they don't have a technical background, and can they still get in this field? Where it's a 2-3 part question. Where should I start to get an entry level job in AI? And is there a computer language that you recommend? Is Python helpful? Where can I start, basically?
That's a great question. I think Bipin, if you want to.
Sure. Yeah. So yeah, Python, obviously, yes. So things so everything is getting standardized and it's easy to learn, in a structured. So it's definitely a best place to start having a little bit more command over the Python as a programming language. And the second part of this is to figure out if you can land into some entry level roles, which primarily would be dealing with annotating the data. Because in AI, we're teaching the system, a computer system, how to learn. And for that, the input data has to be labeled and structured in such a way that the machines can learn from that input data. So data labeling or data annotation is a very important entry level role. And you can also do some Python programming and structuring about data, how to structure the data for machines to learn. So both the data engineering, data annotation, structuring the data, and building that data pipeline to feed into the machines to learn is a step towards that direction. So if you're fairly new and also haven't done much programming work before in life, then that would be much more easy to enter without a lot of barriers. Those are the areas that I would strongly recommend to start looking for is data annotation. There are data annotation specialist role. There are data annotation entry-level jobs. There are also data engineering type roles with Python, where you can start helping getting the data prep activities before the machines, these neural networks or deep learning techniques start to bring the data in. So that would be a good area of entry for someone who's fairly new to this.
Thank you, Bipin. And is there going to be a practical lab associated with the AI for robotics?
So yes and no. Yes, because we would want to open up the lab after the COVID situation gets over, and it's more safer for everyone to work and collaborate closely. And so that's why I said yes. I mean, the original intent was to do it, but if the current situation continues, where everyone needs to be very guarded and protective, and as you know, these are indoor robots, so indoor is not the best place for people to come together. If this situation continues, we are going to open up a live channel where we would have Sudhakar or myself on the floor with the robot, and then while the student community actually works with us in a real-time environment to integrate their machine learning system that they have built during the coursework, and we will help to see how it's been flashed into the robot, and how the robot actually performs that task, whereas you can actually virtually see it from your camera. So that's something that we are thinking as a plan B in order to create an interactive session using the real-time video streaming from the lab. So you get that experience of how the robot performs and how to get feedback from the robot, and how you can then fine-tune refine your models, your machine learning models, before you come to the next session. So that's something we're certainly factoring. But otherwise, in the long run, it is going to be a in-person at the lab feature that we have built into the course.
Thanks so much, Vipin. And just to add to that, we will, we have to follow the state guidelines. So we're updating our website as soon as certain courses are available to be held in person in session. There may be some occasion where there's a hybrid model where some of it's online, some is in class. But again, it's too early for us to say. So we're updating our website as soon as that information is available. And it is course specific. So it's course specific and quarter specific. It's just take it as we come. So just check back on our website. And if it's confusing, just go ahead and email us and we'll help you figure that out. Yes, and this course is available in the summer. It begins on June 30th. Dr. Moines? I think you're muted.
I think there was a question whether it would be offered in winter. I know that in winter there are other things that would be similar, like the Capstone project, AI Capstone project course, that may not be just on focusing on robotics, but on other things, and robotics could be part of it. So if it's not offered as in winter, the Capstone project can be a similar one.
Thanks so much. And there is a chart on the website that says when the courses will be offered. So at this time, what we know that will be offered in winter is on that list. And I'll link it again in the chat.
Yeah, so Dr. Monis actually brings up a good point, which we should have talked a little bit earlier too, is the AI edge, or the embedded AI for the edge applications. And as we all know, robotics is part of that too, because robotics is ultimately an edge system which has hardware and software integrated. And that's also a good offering from UCSC Silicon Valley Extension, as it's also very hands-on, capstone driven, using one of the NVIDIA's edge platforms. So it'll also be giving students a great possibility to build the expertise, just very similar to the robotic space, but it is also at the edge, and it looks at all the elements of the machine learning and execution at the edge. So it's a pretty similar framework of technology, both hardware and software, that would be addressed in that course as well. So that's a great offering to highlight.
Vipin, can you repeat the name of the course?
That's embedded AI.
Okay, I'm going to find it and link it.
Yes, that would be great. Let's see.
Excellent. Okay. Awesome, Dave. And if you have any question, go ahead and make sure you connect with us at our student services team is ready to help you if you are looking to figure out how to plan your summer or fall courses. So again, that email address is right here. Thank you so much to our panel for taking the time today to talk to us about this. It looks like we're just at about time, so if there are no other questions, we could wrap up. Just wanted to thank you again, and this recording will be available on our YouTube channel, and we'll email that out as soon as it's available. Thank you, everyone.
Yeah, thank you. Thank you all. Yeah, have a great afternoon. Take care. Bye-bye.
Thanks
so
everyone
much.
for attending.
Thank you.
Bye.
Bye.